Hello students, welcome back from the Easter holiday. Today we will start Chapter 11.4, Multiplication Law of Probability for Independent Events. And tomorrow we will have a quiz of Chapter 11.3. So let's start. First of all, I would like to introduce a term to you which is independent events. So independent events, just like what independent said, if two events or more are not affected by the occurrence of each other. That means, for example, if event A occurred, it doesn't affect the probability of event B to occur, like this, and vice versa. So here are two examples. First, imagine now we throw a dice and also we toss a coin once. Event A is the dice shows a 6. Event B is the coin shows a tail. It is quite obvious that whether event A occurs or not means no matter the die is a 6 or not a 6, it will not affect the probability of you getting a tail on the coin, right? So these two, event A and B, we call independent. Now the second examples. A box contains 3 green balls and 2 red balls. So now 2 balls are drawn one by one at random with replacement. With replacement means you take the ball and then you put it back. So event A, the first ball is red. So event B, the second ball is green. So in this situation, actually, if you take a red ball as the first one, then actually you will put this red ball into the bin, right? Into the box again. And then you take the second ball. It means for the first draw and the second draw, there are also 3 green balls and 2 red balls in the box, no matter what you have drawn in the first for the first one, right? So means this is also independent. But actually this is quite good example because if it's with replacement, so actually it is independent. But actually if it is not, that means if it is without replacement, that means you take the ball and then you just throw it away. You will not put the ball back to the box. Then whether it is independent or not, so it is actually a doubt. You don't know whether it is independent or not. And actually in the next session we'll talk about more about the not independent situations. So let's go to look at the relations between P, probability of A, probability of B, and probability of A and B. So now Harry draws a ball from a bag containing 1 red ball, 1 yellow ball, and 1 green ball. And then he draws a card from a box containing 4 cards, which are numbered 4, 5, 6, 8. Means that there is a bag and there is a box as well. So event A, he draws a red ball from the bag. Event B, he gets a card greater than 4 from the box. So now 1A are event A and B independent events. So it is quite obvious, right? Because they will not affect each other. So it is yes. So now we try to list out all the possible outcomes in the following tables as we have done before. So the first is R4, means you get a red ball and a number 4 card. And here you will get R5. And here you will get R7 and R8. And for this one you will get Y4, Y5, Y7, Y8. And also for the last row. So if we count all the possible outcomes, there are 12, right? Then now we try to find the following probabilities. PA means what's the probability of getting a red ball. So here you get 12, right? Total possible, how many of them are getting the red ball? You can see 1, 2, 3, and 4, right? So you will get 4 of them. And also, you simplify the answer, you will get 1/3. Okay, how for PB? Get a card greater than 4. Okay, so you get this 3 column, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this 9 out of 12, you will get PB. Then what's the probability of getting PA and B? PA and B? It means you need to get a red ball. At the same time, you need to be greater than 4. So we just look at this, okay, red ball and greater than 4. So mean these 3 numbers. Then we get 1, 2, and 3. So here we get 3 out of 12. But here, actually, I would like to also think these questions in another way. So when you look at this 3/12, okay, actually you can divide into 2 parts. The first is the total possible outcomes. Total possible outcomes, okay, means now actually you are doing 2 steps, right? 2 steps means you use the multiplication law. So for the first one, let's consider you pick a ball. So how many possible outcomes for the ball is you get a red, a yellow, and a green. So there are total 3 possible outcomes, right? And for the numbers, you get 1, 2, 3, 4. So 3 times 4. Actually, this 12, okay, you get the denominator. Then how about now? What is the total possible outcomes favorable to our event A and B? So A and B means red. So you can only take red ball, right? So red ball, you get 1. How about the second step? Greater than 4. Greater than 4, you get 5, 7, and 8. So you get 3 possible outcomes, right? So actually, if they are independent, okay, you will actually find, actually you can just split this 2, right, into 2 fractions. You will find this 1/3 and 3/4. 4 is exactly this 2. Okay, that means here we can actually, in question 3, we can suggest a relations between this is P, A, and B. It will equals to PA times PB. Okay, so here we get the multiplication law for probability. Okay, as well as in the last session, you get the addition law, okay, for probability. So here, we get 2 similar but actually not exactly the same theorem for independent events. If there are 2 events and they are independent, then you will got what we have just now. PA and B equals to PA times PB. And here, for more than 2 events, okay, more than 2 independent events, and they are still all independent to each other, then we get a similar formula, okay? PA1 times PA2 times PA3, okay, up to PAN will equal to PA1 and A2 and okay, up to AN. Okay, so now we go to one example. Here we have group A and group B. Each has 30 people. And 12 people in group A are left. Okay, we just can use a very simple figure. Here we get A and we have 30 people, and we get B and we also get 30 people. So in group A, 12 people are left-handed. so left. So you can actually get this yourself. Okay, so 18 are right. And in group B, 20 will be left-handed, and so you get 10 are right-handed. So after we write down this information, it will actually get easier to do the questions. So now both of them are left-handed. So now the question, one person is chosen from each group. So we take one from A and one from B. So now the probability of both are left-handed. So we simply write both are left. Okay, both are left. So it actually equals to, you get a left from A, right? And you get a left from B. Then here you can imagine, or you can just actually quite obvious that these two are independent, right? Because you take one from A will not affect which one you take from B. So you just get what we have. This is 30. And left from A is there's 12. So you multiply. Here you also 30. Left from B you get 20. So you get the answer 4/15. Okay, so now we go to part B. The person from group A is, so P, okay, left from A, but this time we need to have a right-hander from B. Okay, so we get, okay, again, they are independent. Left from A is 12/30. So how about right from B? So right from B, you see this, you get 10, right? So actually this 10 come from 30 minus 20, right? So you get 10/30. Then we get the answer directly. Okay, so welcome back again from the Easter holiday. So today we just end here. So we just better get some time to just pick up the study again. So now please do a quick practice. I will show you the answer in another video, and also we'll give you some like exercise today. And also please be reminded that tomorrow we will have the quiz chapter 11.3. Okay, see you.